Hi everyone, in this video we will discuss outliers and how to detect outliers using SPSS. Head-on defines outliers as observations with unique combination of characteristics identifiable as distinctly different from other observations. Basically, outliers are extreme values from others. Outliers could be beneficial or problematic. On one hand, outliers can indicate characteristics of the population that would not be discovered in the normal course of analysis. On the other hand, problematic outliers are not representative of the population and can seriously distort statistical tests. In other words, these extreme values will skew the data. These outliers must be detected and handled. How to do that? The easiest way is to use the box plot. We will use each bed dataset as an example. These are 23 variables of this dataset. Note that there are no spaces or special characters in the variable name. The labels can include four details. Measure shows the scale of each variable, nominal, ordinal, or scale. To get the box plot, we go to Analyze, select Descriptive Statistics, and choose Explore. We will move ID to Label Cases box. Then we select X6 to X18 and move them to the dependent list. In Statistics, we select Descriptives, which will give us the box plot. Click Continue and click OK. Output shows us some descriptive information, but we will focus more on the box plot. This is the box plot for X6, which has first quartile, second quartile, third quartile, and fourth quartile. The box plot uses the median and the lower and upper quartiles, defined as the 25th and 75th percentiles. First quartile is the lower quartile, the third quartile is the upper quartile. This means that 50% of the cases lie within the box. The T-bars that extend from the boxes are called inner fences or whiskers. These extend to 1.5 times the height of the box. If the data are distributed normally, approximately 95% of the data are expected to lie within the inner fences. The points are outliers. These are defined as values that do not fall in the inner fences. Outliers are extreme values. The asterisks or stars are extreme outliers. The number indicates the case numbers with outliers. For X6, product quality, there are no outliers. Similarly, we do not see outliers for X7 to X11. For X12, we see some outliers that are outside the inner fences. The next variables that have outliers are X16 and X18. Thus, in this case, we have three variables with outliers and no variables with extreme outliers. The box plot allows us to view the outliers visually. However, it could be problematic if we have a high number of variables, since we'll have to examine a lot of graphs. Note that the box plot only gives us the univariate detection, which helps identify outliers for each variable separately. In multivariate analysis, we have to deal with multiple variables, and it's necessary to use multivariate detection to identify outliers across all variables. A typical multivariate detection method is Mahalanobis D-square. This method works well for multiple variables. This method measures each observation's distance in multi-dimensional space from the mean center of all observations, providing a single value for each observation no matter how many variables are considered. High D-square values represent observations farther from the general distribution of observations in this multidimensional space. SPSS does not have a direct way to determine Mahalanobis d-square. We will need to do this through regression analysis. To do that, we go to Analyze, select Regressions, and choose Linear. In this case, we are not actually performing any actual regression analysis, thus using this as a means to calculate d-square. We add ID to the case labels and add x19 to the dependent box. Then we select x6 to x18 and add them to the independent list. To get the d-square, select Save, which opens the Save window. You can see under Distance, there is a box so-called Mahalanobis. Check this box, click Continue, and click OK. Here is the SPSS output. We will not look at the regression results in this example. You will notice that these square values are not presented in the output. Actually, they will be added to the data. Let's go back to the data and select Variable View. We can see a new variable is added, MAH. These are d-square values. To identify outliers using d-square, we will compute the p-value for the d-square for each case. This is the probability of getting a d-square value as large as the current cases values in a chi-square distribution with the same degrees of freedom. First, we need to find the degree of freedom in this case. We go back to the output and look at ANOVA table. It shows df of 13. To compute p-value for d-square, we go to Transform and select Compute Variable. We will name the target variable p-value d. Under numeric expression, we type 1 minus, and we need to look for the cumulative distribution function for chi-square, which is cdf.chsq. We double click that function, then move MAH variable to the first parameter. For the second parameter, we enter the degrees of freedom, which is 13, and click OK. We will examine the data. A new variable p-value d is added, showing the p-value of the d-square. A p-value less than 0.001 indicates outliers for that case. To speed up the process, we can sort the p-values. Select p-value d column, right-click, and select Sort Ascending. We will have the p-values sorted from lowest to highest. Then select Variable View tab and change the decimals for p-value d to 5. You can see that there are two cases with p-values less than 0.001. And these are outliers. Once outliers are detected, it is important to re-examine these cases along with the box plots to fully understand the nature of these outliers before deciding what to do with them. Problematic outliers can be removed, while beneficial outliers should be kept. That is how to detect outliers using SPSS. Thank you, and bye now.